Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k cubed plus k divided by k is equals to k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we move towards the solution of this problem. So first we move the term k from left hand side to the right hand side, and this will be written as k cubed plus k is equals to, this k is multiplied by this k which is lies into the right hand side. And now in the next step we need more simplifications here, and we get k cubed plus k, and this k multiplied by k becomes k square. And here we move the term k square from right hand side to the left hand side, and this will becomes k cubed minus k square plus k, and this whole equation is equals to 0. And now you see that after this little bit simplification, our given equation becomes cubic equation in k variable. So this means that this equation has 3 or less than or equals to 3 roots. So we need to find all that 3 roots of the given equation. First you see that each of these terms involve k. So we take common k from here, and after taking common k we get the remaining values are, from here we get k square minus, from here we get k only, and from here we get 1, and this whole equation is equals to 0. And now in the next step we divide this equation into the two cases. The first case is we write k is equals to 0, and the second case is we write k square minus k plus 1 is equals to 0. So we divide the above case into the two cases. So we have, this is the first root of the given equation. And now you see that this is the quadratic equation, and we know about that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we use the quadratic formula to solve this quadratic equation. And for this, first we write the coefficients of this equation, and its coefficients are a is equals to 1, b is equals to minus 1, and c is equals to plus 1. And we state the quadratic formula as k is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is our quadratic formula, and here we substitute all the values of a, b and c, and this will be written as k is equals to minus b, the value of b is minus 1 plus minus square root of b square, so b is minus 1 square minus 4 times of a is 1 and c is 1, and it is divided by 2 times of a, and here our a is also equals to 1. And now further in the next step we need more simplifications here, and we get minus times minus becomes plus 1 plus minus square root of this minus 1 square becomes plus 1 minus this is 4 times of 1 is equals to 4, and it is divided by 2 times of 1 is equals to 2. And now in the next step we need more simplifications here, and this will be written as 1 plus minus square root of 1 minus 4 becomes minus 3, and it is divided by 2. So here we just break this fraction and we write the square root sign separately on both of these two values, and we get 1 plus minus square root of 3 into square root of minus 1, and it is divided by 2. So further you know about that the square root of minus 1 is equals to iota, so we get 1 plus minus square root of 3 times of iota, and it is divided by 2. So these are the other two complex roots of the given equation. So finally we have, there are three roots of the given equation, in which the first root k1 is equals to 0 be the real root of the given equation, and K2 is equals to 1 plus square root of 3 iota divided by 2 be the second complex root of the given equation, and K3 is equals to 1 minus square root of 3 iota and it is divided by 2 be the third complex root of the given equation. So finally we have these are the three roots of the given equation which we get here in this method, and this is the our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more interesting and exciting videos.